Yeah, so there's something in the code when I'm iterating over these Lua. Damn. Lua is pretty primitive if it doesn't have that. I mean, it's not Python, so yeah. Let's just try it. $18 now. Interesting. The base color works. All them. Do we have all of them? We got them all. Wow. No, the base color's not working. These are like random colors. So, I think the issue now Alright, it's resolving the file name. Because the textures aren't lowercase yet. Doing that. Texture file name. Okay, well this won't work, but we will fix that. It's just the element symbol. This one needs to be lower. Maybe. Let's do it. Yes, indeedy doodly. Saving some time. Thank you very much. You know, honestly, Resident Text work looked a lot nicer than this. You know, we got some aliasing stuff going on. It's the very first problem I noticed. You know, maybe I can do, make them bigger textures. I don't know how. Let's just take a look. But the fact is that we're able to deliver all of the periodic table this way, and it's not going to take us weeks. So that's a big win. It's trade-off. Like, we don't get the nice artwork that Resident Tech was making. Let me see here real quick. Now this is going to cause the problem that the fonts will be disproportionate. Roughly that. Let's check. Let's take a look. Looks better. Less aliasing. Not bad. Okay, let's move it up a bit. Now we're talking. Now we're cooking. Yeah, so let's go with this. Load them into the game one more time. Take a look. Less aliasing. You know, hopefully it's not too super massive. Now we have another issue that we have, not vignetting, what's that called? You know, I guess it's okay. It is what it is. They're not as nice. Let's try it out. Color. number, symbol, group. Oh, yeah. We're not passing in the color there, of course. That won't work. That's not the problem. Color. So we would do this. There you go. Nah, it doesn't work. I'm not gonna fight it. One step too far. Let's just do this. I believe everything is good. Well, here, they're actually not. Maybe so. Maybe they are. A bit. There could be something going on the Minetest when loading them in there. It's adding some more aliasing. Let's hop over to Minetest. I mean, they're okay. What if I... Can I change them to white? I think these are too... The dark... background's not dark enough yet, so... Let's commit this. This is a big change. Alright. I gotta get my cursor back from Minetest. Escape that. What did we make today? 2 hours. Not bad. Oh no. I pushed it. Oh, okay. Not a problem. Generate textures. I like it better. Let's see if we have a contributing guide. We don't, so I will just add. Which we don't have. 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 We do sort of have that. Okay, a lot of this. I think it's good enough, but... that's what happened earlier. That's what's happening. I'm hitting this tilde key, but it's not a tilde on this keyboard. Looking good. All right, let's do an outro. GitHub's been kind of buggy lately. Oh, I'm not signed in. Yeah. One moment. Cool. Basic pull request. I hope the image files aren't too big. We might need to add binary file support. I forget what it's called again on our Git repository though. All right, it's pretty good. It's like overhyping. It's hyping itself a bit, but yeah. All right. Great pull request. Ready. Let's do an outro. Hello and welcome to a recap of today's open source hangout. We've been working on game development with the Minetest engine. Minetest is an open source game engine for creating voxel games similar to Minecraft. It ships with, actually doesn't ship with any game. It used to. Now we have to add a game called Minetest Game or one of these other games that you can find on ContentDB. We're trying to make our own game using the Minetest engine. And to do this, we're starting out with mods. Our game, Open Learning Quest, is education oriented. We'd like to help introduce kids to STEM concepts, science, technology, engineering, and math concepts, and art and creativity through play, and believe that Minetest is a really good platform for doing so. One of our first mods we've created by Resende Tech is this periodic elements, and he's got the initial mod structure created. He's defined 8 periodic element blocks, hand drawing the textures, and even registered a craft. If you combine a hydrogen and 2 oxygen blocks, you'll get a water source. So you can actually create water from the elements. It's a pretty cool idea. But we discussed a bit, and it's a bit challenging to set up the mod, and we're learning everything, of course. And that took us a week or 2 to get to where we've got. And then we realized creating these by hand is going to, take many weeks, we believe. This is a side project, so we're not able to kind of sit down and do that in one setting, for example. You have to literally paint the pixels by hand, or we can find some other options. What would be the options for automatically generating those? For example, if we wanted to make a big change, like changing the background color of all, blue elements to purple or something, or the text color, we would have to go through and paint those by hand. That doesn't seem very sustainable. So I've taken a first pass at automated generation of the elements. It's not perfect. There's some definite room for improvement, and it doesn't look as nice as the handcrafted ones. I'll just say that. These look very simple, but just nice, clean edges and things like that. So we'll look at the automated approach here now in my pull request. So 124 files changed. I'll take a quick spin through the code. So I introduced a Python virtual environment so we could write a Python script to generate these. I've updated some our README with attribution. I used a font here, we'll see in a moment, to give us a pixel feel. It's a public domain font named Minecraft font. So I'm just giving attribution here. And some instructions for people who want to contribute to this project, how to do that. And then specific instructions for developers working on the textures. You'll need a Python virtual environment, and then you need to activate that. And this is only going to work on Mac and Linux. The Windows is a bit different. I didn't include the Windows activation instructions. I might do that off stream after I summarize this. Install the requirements. There's only one requirement. We'll look at these textures in a moment. Whoa, actually, I misspoke. Well, our top level requirement is the Python imaging library. But I think I froze the environment wrong. Requirements text it's got an incredible amount of dependencies otherwise, this Python image library. I'm surprised. This doesn't seem right, but not natural language toolkit. What? PyQt? I don't know. So I'll check our requirements again. Okay, but so that's how you get your environment set up. Now here's where the specific changes are. We have a CSV file, contains the element number, the full name of the element, the symbol, kind of the abbreviation, element group, and the atomic weight. So we have all this metadata. Here's the first element, hydrogen, symbol is H, it's a non-metal, it's got an atomic weight. So all the metadata is there for all of the elements. That was one of the challenges. We'll have to fact check this. This was generated by Copilot, GitHub Copilot. Here's the font file, it's just a binary file in there. Then here's our Python script. So we're going to load a few dependencies. We're loading a file from the operating system. It's a CSV file, and we're going to generate some images. So we're going to draw some lines in those images, and we're working with the font. Our image is going to be 128 by 128. Now, the previous textures here, these are, I think, 32 by 32. So that's one of the nice things about hand drawing them, is we have really precise control over the pixels, and we don't need a big texture. I'm hoping that switching to this 128 is not going to be too big in terms of the memory footprint, how much disk space and download bandwidth is required to download all the images. I use ping, which should be pretty good at compressing the images. We'll look at the images generated in a moment. And we're going to make a bunch of relative adjustments so that all we really need to do is change the image size, and everything else will scale relatively, except the border. I don't know, perhaps the border should also scale, now that I think of it. We have a 2-pixel width border. So we load the font. We're going to put padding below the symbol and numbers up top. If we look at the image, the number here has some top padding, so we're going to push it down, and the symbol has bottom padding, so we're going to push it up from the edges. And we've got some color definitions, so this will allow us to change the look and feel of the colors to make sure that they are accessible. And then we can quickly change the text color between black and white. The color palette here, these were all fairly light colors, so I used a dark text color. We'll have to find a right balance if we want to switch to white foreground elements. We'll just need a little bit darker background colors. We can tweak this all later. This is a proof of concept. We're just going to generate this texture. This is the kind of the function that does everything. Grabs the color for the, so it takes in the element number, a symbol in a group, it grabs the color for that particular group, and it defaults to white. It's going to generate a new RGB image with the width and height of the image size. And it's just going to fill it with the color. And then it's going to kind of render that image. And then we create a border by kind of drawing a rectangle over that image size. I don't know how this really works, to be honest, but there it is. It was generated by ChatGPT. And I mean, it's probably pretty straightforward, and we can tweak it, and it works. That's the key thing, is it works correctly. The first iteration, it didn't work correctly. And then we're going to grab the font for the symbol and detail. I should probably rename these. That's the bit misnomer there. This should be the symbol and the number, but okay. And we're going to draw text boxes for those and position them. See, here we are, the number and symbol. This should be number font, probably. Yeah, just got some misnomers there. Small things. Draw them both. Save the image texture as a ping file. Not bad. Now this should actually happen beforehand. I just realized, oh, no, we're good to go. So I define the function, then we're going to ensure our textures directory exists, which it does in the repository. And we're going to open the CSV file as a dictionary iterate over each of the rows and create the element texture, calling that function. So pretty straightforward code. Took a couple hours to make, but I think given that we were spending multiple hours to hand draw these and potentially would need to revise them, changing colors or layout and things like that, I believe automation is a good use of our time here. In the power, with GPT, it makes it faster to write these automation scripts. Then we just needed to change our Lua a little bit. Essentially, when instead of registering each block by hand, sort of what we were doing, hydrogen block, helium block, now we're just going to kind of get a string split function. Lua, I guess, doesn't have string splitting like Python. Then we're going to load the file, throw an error if it doesn't exist, skip over the header, and create a local table. I was thinking these dictionaries or a map, but Lua, they're tables. All right, so I'm learning Lua as well. Iterate over each of those, grab the element data, grab that element, and we have this, and put that element into this map, this table, using the element name. That way we can look at it back up later. So then we can close that out and free up the memory a bit, and loop through each of the element in that table, and get the file name and register the node. I got to put some lint here, new lines. So this is just going to take our mod name is periodic elements, and then the element name and block. So periodic elements hydrogen block underscore, and then we have a little bit of metadata and the texture file name, and that you can break it. So this is it. Just repeats that over and over, and I'll clean this up. But yeah, here are the textures. So you can see it just did it all. They don't look bad. And here they are in the game. Sorry, I should have just jumped straight into that. Showing it out. Oh, and by the way, here's our previous emotions mod. We're working on that too. We're not going to be able to automate these emotions, but there's not as many of those. And this art style, I think, is really kind of unique, and wouldn't want to automate this. The the periodic table, well, it's more scientific, so yeah, I think we can automate it. But yeah, one of the problems here, you can see sort of aliasing around the edges, so we don't have that nice crisp pixel look. We lost that. There might be a way we could improve on this. Again, this is the first draft, but I think it does the job, and it's not super obvious. Or like, I don't know, it doesn't look really horrible. It doesn't look great. We can also change the colors so they're more vivid perhaps, and the font again, so it's the foreground elements are white or lighter on darker background. The borders look okay. Okay, but that's an update. This is my little test server here, Apple Orchard. We have a little apple here. So, this has been another open source live code hangout. If you'd like to get involved with this project, you can stop by github.com/openlearningquest. We've got a couple of mods on GitHub under this organization. And this particular mod, the Minetest periodic elements, is available on GitHub. We have a few issues that are good. First issue and help wanted. And we've published our mod here to the Minetest Content DB. Okay, well, thanks for your time. I hope you're doing well, and have a great day.